My name is Velen, and in this Worlds Creator Academy tutorial, we'll cover optimized scripting and physics performance. You'll gain a solid understanding of how to create well-performing, responsive, and reliable worlds. So let's get started. Imagine you've spent countless hours crafting a beautiful interactive world only to find that it's plagued by lag, long loading times, and unresponsive interactions. These performance issues can frustrate your visitors, leading to lower engagement. On the other hand, a seamless experience allows users to immerse themselves fully in your creation without distractions. By prioritizing performance, you'll improve user retention and enable more users to access your world across a wider range of devices. Every interactive object or entity in Worlds includes components that define its behavior and properties. Each component follows a specific life cycle which determines when certain methods are called and executed. Here's the simple rule for optimization. Don't perform calculations more often than necessary because, well, they slow things down. Understanding the component life cycle is essential for optimization. You'll want to place your logic in the most appropriate method for your specific use case. You'll want to avoid unnecessary calculations or redundant execution of code, and you'll want to ensure that your scripts are running efficiently and not causing performance issues. By knowing when each method is called and what its purpose is, you can make informed decisions about where to place your code for optimal performance. In Worlds, a component has a set of predefined methods that execute automatically at specific points. The first method to execute is pre-start. This method is ideal for configuring things that need to be set up before the first user enters a world, such as event subscriptions. Be mindful, however, of what you include here, as too many calculations can delay travel time to the first instance of a world. So in this example here, we're going to be listening to the onPlayer enter world and onPlayer exit world events so that we know when players are active in our world. We've connected these functions within our pre-start method, and then I've tied them into our callbacks that are defined further down in the script. From there, after pre-start, start is called. Start is where you want your object to call into other objects and fetch data from them. The idea basically being that in pre-start, I initialize myself. In start, I initialize based off of others. So in this case, with our start method, we're going to initialize what type of item we're going to grant once they enter the world. Here we go into our props definition. We grab a specific entity, and we get a component from it. Keep in mind the get component only actually returns values when it's called in start or after, so that's why we have to call it here and not in pre-start. Now pre-start and start are each called once for both server and client components when the world starts or when the entity is initialized. For async operations, there are a few different options. Your first option is going to be set interval, which will execute its callback function indefinitely on some sort of time cadence. Be sure that you call clear interval when the operation is no longer needed, as it won't stop on its own. If you only want something to trigger once, you should use set timeout. However, keep in mind that just because an object is no longer useful to you, that doesn't mean that the timeout will get cleared on its own. That's why you should call clear timeout when you know that the timer has not yet completed, but the results of it are no longer needed. And finally, your third option is onUpdate. This is a function that will be called every frame, so it should only really be used for things that require per frame calculations. Whenever possible, you'll want to cache results and check if a recalculation is needed instead of running a recalculation that will just produce the same result. Caching means that we are going to be storing our data separately and that we can access it again in the future whenever that may be. By caching results and checking if a recalculation is needed, you can avoid performing expensive computations on every frame, thereby improving the performance of your scripts. So in this case, I'm running an expensive calculation to figure out my player how much damage they can do. I don't want to be doing this calculation every frame because, well, the value is always going to be the same. So in this case, after I do the calculation once, I cache it off, and then I'll access it in the future whenever my player damages another object or another player. So for example, when moving an object over time, we can store its previous location in a variable. This allows you to reference it during the next frame or whenever you need to determine the object's current location, eliminating redundant calculations. In this case, if we look at our script for constant move, we can see that we're going to be randomizing our position. When we randomize, instead of returning a bunch of data and then forcing to having to recalculate every single time this function is called, instead, we're going to cache off the results of this. This allows us to randomize the position and start, but then sometime in the future, if we decide to call move to, we already have the result available. When using the onUpdate method for per frame calculations, be mindful of performance. Overusing onUpdate or performing unnecessary calculations on every frame can lead to significant performance issues. To optimize your scripts, consider the following guidelines. Only use onUpdate for logic that requires per frame updates. Avoid using it for calculations that can be performed less frequently or cached for later use. So again, going back to our constant mover optimize script, we can see that until we call move to, we're not actually registering for the onUpdate function. Thus, we're not hitting that sort of performance cost of using onUpdate. It's only once we actually have logic that makes use of per frame calculations that we tie into onUpdate. Whenever possible, we want to cache the results of expensive calculations and check if a recalculation is needed before proceeding. One common scenario where caching values can improve performance is when working with CUIs, or custom user interfaces. Instead of deriving values on every frame from what we're going to display in the user interface, you can cache the results and only recalculate when necessary. Let's take an example. When we're displaying a player's score in the CUI, you can cache off the score, and then only when it updates do we then update the binding for the actual UI. So in this case, we'll have a binding for the actual player score in our custom UI component class. From there, basically, until something else decides to change the binding, the UI does nothing. It doesn't recalculate, it doesn't query to see has the score been updated. The UI depends on the external gameplay logic outside of its class to know whether it needs to change and update the score that it displays to the player. By caching values and only recalculating when needed, you can significantly reduce the workload in the onUpdate method and create more efficient scripts. Physics simulations play an important role in creating immersive and interactive experiences and worlds. Keep in mind, though, that complex physics calculations can be computationally expensive, leading to performance issues if not optimized properly. In this section, we'll explore techniques to keep physics calculations in check and ensure smooth performance. One key aspect of physics performance is the application of forces to objects. Applying physics forces to objects on every frame can be costly, especially if the interaction doesn't require it. To optimize physics calculations, we can do the following. We can apply impulses to objects instead of frequently changing their velocity, such as in an update loop. Impulses provide a single instantaneous change in velocity, which can be less taxing on the physics engine. We can also only apply forces when necessary, such as when an object is actively interacting with other objects or responding to user input. Collision detection is another area that can cause performance issues. The complexity of the colliders directly impacts the cost of collision checks. To optimize collision detection, we want to start by simplifying our complex mesh colliders by using default collider gizmos in the desktop editor instead, or by importing our own simplified colliders. Other option is to use trigger volumes to detect players or objects instead of relying on mesh colliders. Since triggers don't have materials or textures, they're more performant for detecting collision events. And finally, you'll want to disable colliders on objects that are out of reach or not intended for interaction, such as distant environment elements like mountains or clouds. When setting up collision, we want to be intentional with the collision type. If an object is not meant to collide with a player, then we should narrow down the collision type to objects only instead of everything. This reduces the number of collision checks the physics engine needs to perform, resulting in better performance for your world. So in this case, if we go into the editor and select, let's for example, this wall up here, I don't expect that an object or player is going to collide with this, so I've made sure that collidable toggle is off. If it was on, then with collision layer everything would be able to collide with it, and that adds additional complexity to our world. But by toggling it off, this makes this one mesh have much less impact on performance in our world than the other ones. By carefully selecting the collision type based on the interaction, you can minimize the physics engine's workload and improve overall performance. Remember, optimizing your scripts, reducing network latency, and minimizing physics costs are essential for creating a smooth and enjoyable experience. Prioritizing performance from day one is crucial for developing high-quality projects. Remember to regularly playtest your world, measure its performance, and iterate based on the results. Don't forget to utilize the debugging and profiling tools to identify bottlenecks and guide your optimization efforts. Check out the resources linked in the description for more detailed information on using these tools. Your dedication to performance will set your world apart and showcase your commitment to creating high-quality experiences. So go forth and optimize. I'll see you in the next video.